Good afternoon, everybody. I'm really happy to be here to share with you the usage of FMI within Airbus. Uh, I am modeling and simulation architect for all engineering of Airbus commercial aircraft. That means that I need to understand our engineers' needs and to provide solution to them. At the same time, I am the FMI representative for Airbus Group. Of course, didn't done this presentation alone. Huh? We are a big team of experts on FMI, and most of them are hidden within the all Airbus teams, but they all contributed in this presentation. Okay. So we are Airbus. We are producing aircraft, helicopters, and also military aircraft. For myself, I'm on the commercial aircraft side. And what you can see is the A350neo, which is one of our latest aircraft. You can see that it is composed of a lot of subsystem and then sub-component, etc. It's a very complex system, as already mentioned by the two previous presenters. Aircraft is a complex system. And you can see all around this aircraft a lot of models, lots of models that we need to integrate. In fact, actually, we have 80% of the model that we are using that are coming from our suppliers or partners. So it's really challenging to perform integration and to perform interoperability between the different models. And the huge task is that now we have to use the models from the design definition to the detailed design verification and also for the test phase. So FMI and Airbus. We are not new to FMI. As you can see, we started to investigate FMI in 2013. At that time, it was the FMI 1.0, the FMI 1.0, and at that time, this standard was considered very promising, but still on a prototype side, on an R&D side. So we don't need to deal with it. So we wait for some years, and in 2016, at the group level, we did an assessment for FMI 2.0, and it works. They have produced a white paper, and they recommend to use FMI 2.0 everywhere it is possible to use it. And then the FMI has been spread across all our divisions and at each product life cycle step. After that, we have the 2003 Modelica conference, during which we decided to re-energize this FMI initiative, because now we have a lot of FMI users, but we are not aligned. Why FMI at Airbus? Obvious answer, because of the complexity of our product. We need to deal with a lot of models, large number of models. We need to integrate them and operate them. and they are coming from a wide range of heterogeneous sources. We don't decide it. The model format. When Rolls-Royce provided their model to be integrated in our aircraft, we are not decided with tool they are producing their models. So we need to do with that. So that leads to major issues. One of them is the time constraint. It arrives that integration was too difficult. And then teams decided to rebuild the model in the same way. So more development time, more verification and validation time, and we are not even sure that the behavior is really the same as the models that have been shared with us. We have also some constraints. Certification is one of them, and we need to ensure proper traceability and to have, instead of dead documents, something more updatable, more agile. So the FMI standard for us is one of the answer. Unfortunately, I have the paper on my computer, but a paper of Andreas Hugen Hans and Torsten Blogwitz. They did a summary for the 10 years of FMI, and in fact, they answer to all our questions. We need to integrate, we need to interoperate a lot of models coming from everywhere. Global overview. As I said, we are using FMI at a different level of product development cycle to support design, verification and validation, and also to support physical pay. And last but not less important one, today we have the rules to use SC and BAC, already presented by Eric Loma at the beginning. We have to use system engineering. It's no more nice to have for us, but our number one signed the paper, stating that all Airbus divisions need to do system engineering and model-based system engineering. Then we guess that we need to be able to deal with models in a more accurate way. Here we have first example of how we are using FMI. It is in the power plant center of competence to perform design verification with the specification model. In fact, we have the specification models of our full system in a certain tool, and we demonstrate that we are able to ingest external model coming from suppliers in this specification system, and we managed to obtain good results. And the game was to change the tools that produce the FMI and to redo the same calculation. It works very well, and then they use it in order to perform design optimization. Same game. They used the same detailed model, the same detailed physical model, and they exported from different tools, and they use it in their main simulation framework. This is the good part, the exposed part of the iceberg. The hidden part is that in a power plant center of competence, they are integrating a lot of models. But the good thing is they are trying to use FMI a lot. So they are facing a lot of issues. I didn't list them here, but we have defined clearly the different issues that you have. One of them was, for instance, computation time limitation when we are using co-simulation. But this is inherent to the constraint to have a fixed step time solver. This is a very good example provided by aircraft cabin. The aircraft cabin department tried to use the standard all along the V cycle, from design to implementation on hardware. And the game was to use the same detailed model to encapsulate it into FMU and to reuse it when it is requested. And unfortunately, I have also the video on my computer. I'm not able to share it, but only to show it. But it was really funny. They were really happy to make run the FMI for model in the loop, for software in the loop, and even for the hardware in the loop. They have the FMI, they have the controller, and they are playing with it. Here we have the application for systems, COC. Systems is mainly avionics systems. At Airbus, we have our internal procedure. We have our internal standard, which is the AP 2633. Now it is AIMO 2633. But the idea was to ensure the consistency and to ensure that we are connecting our different model in the right way. This procedure leads to process, to method and tools, and for instance to integrate a model that is coming from our partners. They are producing the engine model. Then we need to integrate it into our full system. We need to make it compliant to this standard AP 2633. And when we need to update the version of the tools that implement the AP 623, it cost us 1 month full work. So it's a huge cost. So why not FMI? What we did is to build a wrapper from FMI. Then we are receiving the models from our partners, our suppliers. They are encapsulated into FMI, into FMU. And above, we have the encapsulation by the wrapper. And we are able to use the FMU in our simulation platform. This is a very great progress, because now we are extending the capability to use models that are coming from everywhere without making a big effort. Here we have the example of the space systems. Space systems have as constraint, which is ECSS SMP standard. So they need to also to comply with the standard. Same as avionics systems. What they did is to build an encapsulation of FMI. This encapsulation will ensure that the FMI will be compliant to the requested standard. And they have extended in a very good way the list of the models that they can integrate into their simulation platform. Yeah. Okay, so regarding the adoption, from exploration mode at the beginning, we have a recommendation, and we have a lot of people that try to use FMI. And what we have in 2025 is an Airbus community with near 100 engineers. We have JSite Confluence pages that are sharing knowledge about FMI, where everywhere in power plant, cabin systems, and in the next-gen program, fuel cell, H2 systems, etc. Here are a list of complaints of our users. It's a short list. Of course, we have a big list, but we just want to say that, okay, FMI is still ongoing. Its integration is on the way. And it's good to have these complaints, because then we can submit our request to the standard, but also to the vendors that integrate the standard. How to improve? From our side, the improvement, as I said, was to build community, to better share the knowledge around FMI, and to go in the same way. We need also to show them that it's not a big step to go this standard. Okay, this is let's say how to improve. Conclusion and way forward. Today we are mainly using the FMI 2.0. It is well used within our divisions all along the cycle. It's an enabler for end-to-end digital continuity, exchanging model, and it may help us to save time. Our needs: easier integration, enable interoperability, improve reusability, traceability, and to also ensure performance in terms of time calculation. So our expectations, we want to go to FMI 3.0. FMI 3.0 promises a lot of very interesting features for us. But the thing is that its implementation, it's not so clear, and it's not full enough. So we need to have a clear view on what part of FMI 3.0 has been implemented already. We want to make FMI easy, so to have guidelines on main topic, recommendations, etc. It's really funny because the opening speech of Dirk Zimmer was very encouraging, because he answered to most of our questions in terms of sharing knowledge. We need that. Okay, so that's all for me.